Hello students, welcome back to the classroom point. In our previous class, we calculated the concentration of H plus ion relation with the EMF of the hydrogen electrode. So in our today's class, we are going to discuss the concentration cells and their different type of the concentration cells. So let's begin the class. Concentration cells. So basically concentration cells are of two types. What are the meaning of the concentration cells? Means these are the cells where they differ by the concentration. So the concentration they differ maybe either in terms of the electrode or in the terms of the electrolyte. That's the reason why concentration cells are of two types. They are electrolyte concentration cells and electrode concentration cells. So meaning is, in case of electrolyte concentration cells, these cells differ in the concentration of the electrolyte solution taken. And in the case of the electrode concentration cells, these cells differ in the concentration of the electrode. So, but whatever it may be, in both cases, the concentration cells, for all type of concentration cells, E0 value to be taken as 0.00 volts. The reason is, as long as the electrode don't changes, so E0 value also do not change. That's why for all concentration cells, we take the E0 value is equals to 0.00 volts. So now let us discuss about the electrolyte concentration cells. Electrolyte concentration cells. So the meaning of electrolyte concentration cells is, in this type of the cells, identical electrodes are placed in the same electrolyte solution having the different concentration taken in the two different beakers. So imagine here, we shall take two beakers. In these two beakers, we place same electrode and same electrolytic solution. But the concentration of these two electrolytic solutions is different. Let it be, this is the C1 concentration, this is C2 concentration. These two are directly connected by the wire. So this type of electrolyte concentration cells having the identical electrodes dipped in the same type of electrolyte solution having the different concentration. So now the source of electrical energy is due to the diffusion of the energy from the higher concentration to the lower concentration. Whichever the concentration is higher, from there to lower concentration, the diffusion of the electrical energy passes. Now, initially, there is a large difference between the concentration of the both of these electrolyte solutions taken in the two different beakers. But when time passes, slowly the concentration of the solutions try to become the equal. Why? Because in one particular electrolytic solution beaker, anode reaction takes place so that the concentration of the solution gradually increases, other side gradually decreases. So that's why after certain time, the concentration of the both of the electrolytic solutions becomes equal and the EMF of the cell becomes equals to the zero. So that's the reason why in the case of the concentration cells, particularly electrolyte concentration cells, the EMF value is very high in the initial of the reactions, but gradually decreases when time passes. Now let us take an example how to represent this type of the concentration cells. So example is a metal rod. This is anode I am taking here. This is the cathode department. So a metal in the solid state dipped in its respect to ionic solution, same metal ionic solution Mn plus aqueous form. Its concentration let us take as the C1 salt bridge. Next one, another electrolyte solution. Again, same metal and its respect to ionic solution. Aqueous solution, concentration is C2, metal rod dipped is in the solid state. So let us take an example. This is a general example. If you take zinc, so zinc rod you dip into the zinc sulfate solution. Here also zinc rod is dipped into the zinc sulfate solution. Means in both cases metal rod is same and electrolyte solution also same. But where they are differing is only the concentration of the electrolyte. So let us take here now. So I am going to take the zinc rod which is dipped in the zinc sulfate or zinc ionic solution. Aqueous state, concentration of this particular electrolyte is C1 and other electrolyte is taken as C2, that is in the aqueous form. Now zinc rod in the solid state. You can take silver also. For example, silver rod is dipped in the silver nitrate solution. So silver in the solid state dipped in the its ionic solution aqueous form having the C1 concentration. Again Ag plus of the other cathode solution aqueous state, concentration is C2 by silver metallic rod in the solid state. Similar one you can apply to the hydrogen electrode also. If you take two different hydrogen electrodes having the different concentration of the HCl but the same electrode concentration, then in such cases platinum solid in which hydrogen gas is adsorbed. This hydrogen gas adsorbed is having the 1 atmospheric pressure. H plus ion is in the aqueous form. Now its concentration is C1, different concentration of electrolytes. H2 should not be different. Why? Because this is electrode, this is electrolyte. Double vertical line, again H plus, aqueous form, C2 concentration, H2 in the gaseous state, its pressure is 1 atmosphere which is adsorbed over the surface of the platinum in the solid state. Then how to write down these reactions? See, all these reactions, these electrolyte concentration cells are also two categories here. This is reversible with respect to cation and reversible with respect to anion. These all comes under the category of the reversible with respect to cation. Same cation is mentioned both sides. That's why it is called the reversible with respect to the cation. Reversible with respect to the anion means here we can take the chlorine electrode. Chlorine electrode here is platinum solid state on which chlorine gas is adsorbed. It has some pressure. Let us take it as a 1 atmospheric pressure. Now chloride ion, anion is present now. Anion is present in the aqueous form. Its concentration is C1. Next again anion, aqueous form, concentration is C2, Cl2, gaseous state, 1 atmosphere I am considering here, platinum solid state. So here anions are present. So such type of the electrolytic solutions whose anionic concentration is different but both sides same anion is produced, they are called as the electrolyte concentration cells reversible with respect to the anion. Now let us take this general equation and how to find out the EMF of the electrolyte solution, electrolyte concentration cells. Now we know that this particular one is nothing but the reaction taken place at anode, and this one is taken place at the cathode. So first of all, let's write down the reaction at anode. So anode, which change is taking place? Metal is dissolving as Mn plus ion. So here I am taking metal solid dissolves as Mn plus ion, aqueous state with C1 concentration, releasing n number of electrons. Now reaction taken place at cathode. Cathode means this particular part. So in this area, how the reaction is taken place? Mn plus ion is depositing as metal. So here I can take this one as metal ion in the aqueous state having C2 concentration gaining n number of electrons changes to the metal and deposits as solid. So that if you write down the total reaction, solid concentrations to be taken as unity so that they cancel out, n number of electrons also cancel out. So final terms remains in the solution are metal ions n plus, aqueous state with C2 concentration changes to the Mn plus ion, aqueous state with C1 concentration. So to this, let us try to apply the Nernst equation. So when you apply the Nernst equation, so E cell I am taking directly. You know that as I said, E naught cell value is equals to 0 for the concentration cells. So directly 0 I am taking here. And all these derivations are taken at the 298 kelvins. That's why 2.303 R by N F value taken as the directly RT by F value taken as the 0.59. So E cell value is equal directly value I am writing here. E naught cell value is taken as 0 for all type of concentration cells and the values derivations taken at the 298 kelvins. That's why 2.303 RT by F value directly I am taking as a 0.059. So I can write down this one as minus 0.059 by n number of electrons are involved, n into log concentration of this one product Mn plus, that is the first one, divided by concentration of the metal ion, second one. See, this metal ion is present at the anode. So this I can take in as anode. This metal ion present in the cathode compartment, so that I can take this one as the cathode. Usually in the reaction, anode is present on the left hand side, cathode is present on the right hand side. So here you can write down the LH side and as RHS, left hand side electrode and right hand side electrode. So now E cell is equals to minus 0.059 by N into log. This concentration is C1. So directly I am taking the C1 by C2, or else concentration of the electrolytic solution at the anode compartment divided by concentration of the electrolyte solution at the cathode compartment. Now, how to improve this value? This also can be written as E cell is equals to 0.059 by N into log C2 by C1. So from this, what other information we can derive it? So I will erase this particular part to write down some other information. So this equation, let's write down once again here. E cell is equals to 0.059 by N into log C2 by C1. So the information which we can derive from this one is, when the concentration of C2 is more than C1, then E cell value is equals to positive. So when C2 is greater than C1, or else C2 meaning is right hand side electrode concentration. So C2 of RHS, if it is greater than the C1 of LHS, then E cell value is equals to positive. When E cell value equals to positive, delta G value is equals to negative. Such type of the cells are possible, so they are known as the spontaneous reactions. This is spontaneous and also known as the exergonic. Now, when C2 is less than C1, or else C2 of RHS less than C1 of LHS, then E cell is equals to negative and delta G value becomes positive, then such a cell is not possible, so that it is known as the non-spontaneous, and it is known as the endergonic. So what is the meaning of exergonic and endergonic? We know that when delta H is equals to negative, it is known as exothermic. Delta H equals to positive means endothermic. So exothermic, thermal means heat energy released. Endothermic means heat energy is absorbed. But here there is no heat energy changes are taken place. But the negative value represents the outside and the positive value represents the inside. That meaning is the process is possible in these cases, the reaction is not possible in these cases. So in case of the delta G, instead of using the endothermic and exothermic, we use the exergonic and endergonic terms. Now let us see the other electrode potentials. EMF of concentration cell made by using hydrogen electrode. So we are taking the concentration cells that is made by the hydrogen electrode. So basically we are discussing the electrolyte concentration cells that is made by the hydrogen electrode. That means H plus ion concentrations are different because here electrolyte is H plus ion. So now let us try to represent this equation. Platinum solid, hydrogen gas state, 1 atmosphere, H plus ion in aqueous form, its concentration is C1. Again H plus ion in the cathode compartment having the C2 concentration, H2 in the gaseous state having again 1 atmospheric pressure which is absorbed over the surface of the platinum in the solid state. So let us write down the anode reactions as well as cathode reaction. This is the reaction taken place at anode. This is the reaction taken place at the cathode. So anode reaction is H2 gaseous state where 1 atmospheric pressure it has, oxidizes to 2 H plus ions. In aqueous state concentration C1 plus 2 electrons are released. Next cathode reaction, hydrogen H plus ion reduced to hydrogen gas. So 2 H plus ions in aqueous form having the C2 concentration gains 2 moles of electrons, reduces to the hydrogen gas at 1 atmospheric pressure. Now overall reaction, in overall reaction common species 2 electrons cancel out and hydrogen gas also cancel out. Finally electrolyte is present. So 2 H plus ion in aqueous state with C2 concentration finally changes to the 2 H plus ion aqueous state with C1 concentration. So now let us try to apply the Nernst equation for this. That is E cell, anyhow E naught cell value is 0. So minus 0.059 by 2 moles of electrons are exchanged in these reactions into log concentration of the product. This one C1, reactant is C2. So concentration of H plus ion by concentration of the H plus ion, product is C1, so that I am taking 1 square, this I am taking the second ion whose concentration is square because 2 moles are involved here. Now this value can be written as E cell is equals to minus 0.059 by 2 into log. Since complete square is present here, I can write down the concentration of the H plus 1 by concentration of the H plus 2 whole square. Square, this value cancel out. So that I can write down the E cell is equals to minus 0.059 into log concentration of the H plus ion 1 minus log concentration of the H plus ion of 2. Now concentration of the H plus ion 1 meaning is here. See, this is C1 concentration. This C1 belongs to the anode. So this H plus ion usually belongs to the which one? Anode electrolyte. This H plus ion belongs to the cathode electrolyte. Now use this minus symbol and multiply the entire value so that we get the E cell equals to 0.059 into minus log concentration of H plus ion of the anode plus log concentration of H plus ion of cathode. Minus log concentration of H plus ion means that is called the pH. Plus log concentration of H plus ion means it is a minus pH. So I can write down this equation as E cell is equals to 0.059 into pH of anode minus pH of cathode. pH of anode minus pH of cathode. So pH of anode value when increases greater than the cathode, E cell value will be higher. pH of the anode is more means concentration of the H plus ion is less. Lower the H plus ion concentration, higher will be the pH value. So when pH of the anode is more than the pH of the cathode, then E cell value is higher. When this difference value increases, E cell value also increases. When the difference value decreases, E cell value gradually decreases. So pH of the anode when increases, automatically E cell value also increases. pH of the anode increase means concentration of the H plus ion is less. Here concentration of the H plus ion should be more. Why? Because pH is inversely proportional to the concentration of H plus ion. When H plus ion concentration increase, pH value gradually decrease. That meaning is, so higher the concentration of the H plus ion taken in the cathode compartment and lower the concentration of H plus ion taken in the anode compartment shall produce the more EMF of this cell.